We are living in the midst of a revolution. In an age where supercomputers dominate every existing field of knowledge, we owe everything we know to these super machines. From predicting the weather to car designs and simulations for safer driving, these computers have done it all. But what if I tell you that in the future, computers will be able to find a cure for cancer? What if they can predict the movement of the stock market 1,000 times faster? What if I tell you that a hurricane can be predicted from a flutter of a butterfly's wings?
Through quantum mechanics, quantum computers might be able to do all of these things and more, making it possible to solve problems much faster and more efficiently than supercomputers. Here's one of the concepts that comes into play when talking about quantum mechanics.
Picture this. Of all the days you could have done this, today you forgot your glasses. You have to squint really hard to see things. Like, really hard. From your perspective, you would probably see two people interacting with each other. But with the help of a camera, it's not all it seems. This is a vital aspect of quantum mechanics explaining the interaction of charged particles. But what exactly happens during the interaction? The thing is, we don't exactly know. And that all comes down to a concept called the Heisenberg uncertainty principle.
We don't really know what happens when we reach such a tiny scale, but we can assume. This is the Heisenberg uncertainty principle, where we can't know an object's position and velocity at the same point in time.
Set heads.
This is a good example of this principle. At a high shutter speed, we could tell that there is an object being exchanged and what it looks like, but we couldn't tell how fast it's going. At a low shutter speed, we have an idea that the object is hurtling fast, but nothing about its exact position. In a larger scheme of things, the whole interaction can actually be represented by illustrations called the Feynman diagrams. This diagram is a simple but beautiful representation of the interaction between our charged particles. Simply put, the two curved lines at the side represent the movement of the particles, while the squiggly line at the center represents the exchange of a photon. It's possible that only one photon is exchanged, or two, or an exchange of photons within the same particle, or even an interaction involving antimatter. The important thing is, a Feynman diagram doesn't exactly represent what's going on in the interaction, but rather gives a visualization from the equation of the interaction. The more complicated the diagram, the less likely it is to occur. In the simplest and most likely version of the diagram, we see two electrons approaching each other, eventually colliding as they fire virtual photons at each other, sending both flying in opposite directions.
It's the simple concepts like this that could potentially power the future of computers, by using ideas at a quantum scale to solve the cosmic problems of our world and the universe.